We'll start in 1 minute. We'll start the test 3 review over the chapter 7 and chapter 8 material. Remember that test 3 is on Thursday, 2 days from now. I'll send a Zoom link for that tomorrow. So we'll begin the test 3 review sheet. Yeah, number 1, find the restricted values for each rational expression and then solve each equation. So on this first equation on the left, we'll note that the denominator x squared minus 5x plus 4 is the product of the other two denominators, x minus 4 and x minus 1. There are only two restricted values. One is positive 4, the other one is positive 1. And the least common denominator is in factored form is x minus 4 times x minus 1. So if we multiply every term on both sides by the least common denominator, we'll get x squared minus 5x plus 4 over 1 times x minus 10 over x squared minus 5x plus 4. And then the next time I'll write the least common denominator in factored form, x minus 4 times x minus 1 over 1 times 6 over x minus 4. So I didn't manage for the space very well, but we'll deal with that in a minute. So on the right-hand side, multiply x minus 4 times x minus 1 by 3 over x minus 1. So we get a bunch of cancellations on the left-hand side. X squared minus 5x plus 4 divided by x squared minus 5x plus 4 equals 1. So we're just left with x minus 10. Then in the next product, the x minus 4 factors cancel, so we're left with plus x minus 1 times 6. And on the right-hand side of the equation, the x minus 1 factors cancel, so we get x minus 4 times 3. Okay, so we'll solve this equation, x minus 10, and then plus 6x minus 6. On the right-hand side, 3x minus 12. Simplify the left-hand side, combine like terms, x plus 6x is 7x, minus 10 minus 6 is minus 16, equals 3x minus 12. Then we can subtract 3x from both sides. So we'll get 4x minus 16 equals negative 12. Then divide both, or add 16 to both sides, and we get 4x equals 4. Divide both sides by 4, x equals 1. One of the restricted values is 1, so that means the equation has no solution. So this equation has no solution. Okay, on another piece of paper, I'll write the other equation. So we'll have more room for that one. Okay, so here's the other equation. So notice this denominator, y squared minus 11y plus 28, is equal to y minus 7 times y minus 4. So there are just two restricted values. Y can't be 7 and y can't be 4. And the least common denominator is y minus 7 times y minus 4. Or in expanded form, the least common denominator is y squared minus 11y plus 28. So we multiply every term on both sides by the least common denominator. On the left-hand side of the equation, y squared minus 11y plus 28 over 1 times y plus 8 over y squared minus 11y plus 28. On the right-hand side, multiply each of those terms by the least common denominator, y minus 7 times y minus 4 times 5 over y minus 7, and then also y minus 7 times y minus 4 over 1 times 2 over y minus 4. Okay, we get cancellations on the left-hand side, y squared minus 11y plus 28 divided by y squared minus 11 plus 28 is 1. We're just left with y plus 8. On the right-hand side, in this first product, the factor y minus 7 from the numerator divided by y minus 7 from the denominator, those cancel each other out. We're left with y minus 4 times 5. Then the next product, the y minus 4 factors cancel, and we have plus y minus 7 times 2. So this is a pretty simple equation to solve for y. Distribute multiplication here, y minus 4 times 5 is 5y minus 20, and y minus 7 times 2 is 2y minus 14. Combine the like terms on the right-hand side. 5y plus 7y is, 5y plus 2y is 7y, and minus 20 minus 14 is minus 34. Now let's add 34 to both sides. So we get y plus 42 equals 7y. Then subtract y from both sides. 42 equals 6y. Then lastly, divide both sides by 6. 42 divided by 6 is 7. we get y equals 7. But 7 is a restricted value. So again, we have no solution. So a lot of our examples, as well as examples in Newton, end up with no solution because of the restricted value. But just keep in mind that's not always going to happen. So just take each equation one at a time. Hey, let's return to the other sheet. We'll look at these word problems. Okay, this one says Ralph takes 3 hours to put in a slab of concrete. If Don helps, it takes them 2 hours to do the job. Find how long it would take Don to do the job by himself. Okay, so this equation is this problem is a work problem. So equations have the form rate times time equals 1, where 1 refers to the job or the task that is accomplished. Okay, so when Ralph works by himself, he can put in a slab of concrete in 3 hours. So for Ralph, we can write an equation of the form rate times time equals 1. So Ralph works at a certain rate. I'll use R sub R for the rate that Ralph works. In 3 hours, he can put in a slab of concrete. If Don helps, it takes them 2 hours to do the job. So they work together and they can complete the job in 2 hours. And then it says, find how long it would take Don to do the job by himself. So for Don works at a certain rate. And in a certain amount of time, he'll be able to do the job. But we don't know what that amount of time is yet. That's what we're supposed to find. So we assign a variable like t to represent the amount of time it would take Don to do the job by himself. But we are told that when they work together, they can do the job in 2 hours. So when they work together, it's Ralph's rate plus Don's rate times 2 hours equals 1 job completed. So when they work together, we have rate times time equals 1. Okay, so we want an equation whose only variable is capital T. So the next step, we solve each of those 3 equations for the rates. For Ralph's equation, his rate times 3 hours equals 1. So Ralph's rate is 1/3, which means that he can complete 1/3 of the job per hour. That's his hourly rate. Don's rate is 1/t. We don't know how many hours it's going to take him yet. And when they work together, Ralph's rate plus Don's rate is 1/2. Okay, so in this equation, Ralph's rate plus Don's rate equals 1/2. We're going to replace Ralph's rate with 1/3, and Don's rate, we will replace this with 1/t. So we get 1/3 plus 1/t equals 1/2. So finally, we have an equation whose only variable is capital T, and we know how to solve this equation. So what's the next step? Yeah, what's the next step? We want to solve for T. We have 1/3 plus 1 over T equals 1/2. Okay, so the next step is to find the least common denominator. There is a suggestion that we cross multiply, but in this current state, cross multiplying will not work. We only want to cross multiply if we have a single fraction on each side of the equation. But the left-hand side has a sum of two fractions. So in its current, how do you call it? In its current state, we can't cross multiply. But we do want to find the least common multiple of the denominators. The denominators are 3t and 2. So the least common denominator is 6 times t. And then we're going to multiply every term on both sides by the least common denominator. So 6t over 1 times 1/3 plus 6t over 1 times 1 over t equals 6t over 1 times 1/2. 6t over 1 times 1/3, that simplifies to 2 times t. And 6t over 1 times 1 over t, the t's cancel, that simplifies to plus 6. And on the right-hand side, 6t over 1 times 1/2 simplifies to 3t. And then if we subtract 2t from both sides, we get 6 equals t. So 6 hours is how long it would take Don to do the job himself. So I can squeeze that in down here. Don can do the job in 6 hours. Okay, the next problem. This one is a uniform motion problem. So rate times time equals distance. Or some variation of rate times time equals distance, like rate equals distance divided by time, or time is equal to distance divided by rate. So whatever one of those three equivalent equations is needed, those we will use. So this one says Nate walked 12 miles uphill and then walked back the 12 miles downhill. So one thing we know from the first sentence, the distance going uphill was 12 miles, and the distance going back downhill was 12 miles. In the second sentence, it says he walked 2 miles per hour faster going downhill than uphill. Okay, so that's information about the rate. he walked 2 miles per hour faster going downhill than he did uphill. In the third sentence, the walk uphill took 1 hour longer than the walk downhill. So in the third sentence, we have information about time. And then it says, find how fast Nate walked uphill. So we want to find the rate that he was walking when he was going uphill. Okay, in these word problems, we identify what it is that we're supposed to find, and then assign a variable to represent that quantity. So you can use any letter that you want. So I'll just pick X to be Nate's rate walking uphill. And it will be measured in miles per hour, just based upon the other information. So X is Nate's rate when walking uphill. And I'll just note that it's in miles per hour. Okay, what other information is given? Well, in the second sentence, we're told something about the rate going downhill. When he was walking downhill, he was walking 2 miles per hour faster than when he was walking uphill. So if X is the rate walking uphill, the rate walking downhill is how much? X plus 2 miles per hour. So he walked 2 miles per hour faster going downhill than uphill. If he's going X miles per hour uphill and he's walking 2 miles per hour faster going downhill, then X plus 2 represents his rate walking downhill. So Nate's rate walking downhill. In miles per hour. Okay, we can start setting up equations. Let's write an equation for walking uphill, and then another equation for walking downhill. So rate times time equals distance. So when he's walking uphill, his rate is X miles per hour. And for the amount of time, I'm going to use capital T sub U for the amount of time it takes him to walk a distance of 12 miles uphill. Then when Nate is walking downhill, his rate is X plus 2 miles per hour. And for the amount of time, I'm going to write T sub D to represent the amount of time it takes him to walk 12 miles going downhill. Okay, we are given some information about times. So what's given about the amount of time, or as the amount of time to walk 12 miles uphill as it relates to the amount of time it takes to walk 12 miles downhill. Yeah, let's see. In the third sentence, we're told that walking uphill took 1 hour longer than walking downhill. So it seems to make sense. His rate is slower going uphill, so it should take more time. So this bit of information all the information is important, but this is going to help us get our equation whose only variable is x. That's what we want. We want to solve for x, so we need an equation whose only variable is x. Okay, so t sub u, that's the amount of time we're using, or that represents the amount of time it takes him to walk 12 miles uphill. And this amount of time, t sub u, is greater than the other amount of time, the amount of time it took him to walk 12 miles downhill. So t sub u is greater than t sub d by how much? By 1 hour. Okay, so now we're just a couple of steps away from getting our equation, whose only variable is x. So a couple of things to do. Note that if t sub u is greater than t sub d by 1, one way to get an equation out of that information is t sub u minus t sub d equals 1. So if you subtract the smaller number from the larger number, it's equal to 1, because we know the difference is 1. Okay, that's a good start. For the uphill equation, we're going to solve for t sub u, so we divide both sides by x. So the time, t sub u, is equal to distance divided by rate. In this case, 12 divided by x. Then solve the other equation for its time, t sub d. For this one, we divide both sides by x plus 2. So t sub d is equal to 12 divided by x plus 2. Okay, we're going to combine the results of these three equations to get our equation whose only variable is x. So in this equation, t sub u minus t sub d equals 1. We're going to replace t sub u with 12 divided by x. And then when we subtract t sub d, we're going to replace t sub d with 12 divided by x plus 2. And then the 1 on the right-hand side stays the same. Okay, so we get 12 divided by x minus 12 divided by x plus 2 equals 1. Okay, well, it was a fair amount of work just to get the equation. Now we have to solve it. So the technique is to identify the least common denominator and then multiply every term on both sides by the least common denominator. The least common denominator is x times the binomial x plus 2. When we multiply x times x plus 2 times 12 over x, the x's are going to cancel, and we'll just be left with 12 times x plus 2. And then remember, we have subtraction. You always have to be careful, especially with subtraction. We're going to multiply 12 over x plus 2 times x plus 2. This time the x plus 2 factors cancel, so we're just left with minus 12x. And then on the right-hand side, multiply 1 times the least common denominator. So we'll multiply 1 times the product of x times x plus 2, which is x squared plus 2x. So the right-hand side becomes x squared plus 2x. And then we just solve this equation. On the left-hand side, 12x plus 24 minus 12x equals x squared plus 2x. The 12x minus 12x, those combine to make 0. So we'll just subtract 24 from both sides, and we'll get 0 equals x squared plus 2x minus 24. And we can pretty easily solve this equation by factoring. One of the factors is x plus 6, and the other factor is x minus 4. This equation has two solutions, but only one of them is going to make sense. One of the solutions is x equals negative 6. The other solution is x equals positive 4. So we want the positive solution. What would it mean if Nate walked at negative 6 miles per hour? So that doesn't make sense. But x equals positive 4, that makes sense. Nate's rate walking uphill was 4 miles per hour. Okay, let's move on to the next page. Solve the rational inequalities. Write solutions in algebraic and interval notation. Okay, this is set up pretty nicely. X plus 1 divided by x minus 5 is less than or equal to 0. So when solving rational inequalities, we want one side to be 0, which we already have. And then we want to find the endpoints of the intervals. The endpoints of the intervals are the x values that make the numerator 0 combined with the x values that make the denominator 0. The x value that makes the numerator 0 is negative 1. And the x value that makes the denominator 0 is positive 5. Since the inequality is less than or equal to 0, are we going to include endpoints or exclude endpoints or a combination? Are we going to exclude one of the endpoints? Which one are we going to exclude? So nobody knows, I guess. Remember that x values that come from denominators are never, ever part of the solution set. because division by 0 is undefined. So if you replace x with 5, we're dividing by 0, but that is undefined. So we're going to exclude 5 from the endpoint, or from the solution set, because it's the x value that makes the denominator 0. So exclude from the solution set. The x value that makes the numerator 0 may or may not be included. It depends on the inequality. Since this inequality is less than or equal to 0, we're going to include -1. So the or equal to 0 means that the numerator can be 0. So in a fraction, if the numerator is 0 and the denominator is non-zero, the value is 0. So we're including x equals -1 in the solution set. We always exclude x values that come from the denominator. Okay, the particular method for solving this is to use the endpoints to divide the number line into separate intervals. So we have 2 endpoints, so the number line is divided into 3 separate intervals. So we pick a test point from each interval. In the first interval on the left, let's pick x to be -2. And then in the inequality, replace x with -2. So -2 plus 1 in the numerator, -2 minus 5 in the denominator. So the numerator is -1, the denominator is -7. -1 divided by -7 is positive 1/7. But 1/7 less than or equal to 0 is false. So none of the numbers in the interval from -infinity to -1 are solutions. In the second interval, pick a number between -1 and 5. We can pick 0 to be the test point. And then in the inequality, we have 0 plus 1 over 0 minus 5, or -1/5. And -1/5 less than or equal to 0 is true. So all of the numbers between -1 and 5 are solutions. In the third interval, pick a number greater than 5, like 6, and then replace every x in the inequality with 6. So 6 plus 1 divided by 6 minus 5, or 7 over 1, less than or equal to 0. This one is false. So none of the numbers from 5 to infinity are solutions. We already determined which endpoints are included and which ones are excluded. So we're including -1, but we're excluding 5. So graphically, this is what the solution set looks like. The algebraic notation, we write -1 is less than or equal to x, which is less than 5. The word and is implied in this compound inequality, but we don't write the word and. -1 is less than or equal to x, and x is less than 5. And means x satisfies 2 conditions at once. The interval notation is just bracket -1 comma 5 parenthesis. So this top one is the algebraic notation. And the bottom is the interval notation. All right, the next inequality, the only difference between the inequality in part B from part A is that this time it's greater than or equal to 0. So we've done a lot of the work already. The endpoints are still the same. The endpoints are -1 and +5. We're still excluding 5 because it's the x value that makes the denominator 0. And we're still including -1 because 0 greater than or equal to 0 is true. So we include -1. So we can abbreviate this a little bit instead of going through the whole process. In this first interval, as we saw in part A, an x value from the first interval makes the fraction negative. Sorry, makes the fraction positive. Sorry about that. Yeah, when we tested -2 up here, we got +1/7. So for this inequality, a positive number greater than or equal to 0 is true. So we're going to get yes in this interval. In the middle interval, when we picked x to be 0 as our test point, the fraction is negative. But in part B, a negative number greater than or equal to 0 is false. So none of those numbers between -1 and 5 are solutions. Then in the third interval, a test point makes the fraction positive. So a positive number greater than or equal to 0 is true. Okay, so graphically, we put a bracket at -1 opening to the left and shade all of the numbers to the left. At 5, we put a parenthesis opening to the right and shading everything to the right. Okay, so the algebraic notation is x is less than or equal to -1 or x is greater than 5. This is the algebraic notation. The interval notation, -∞, -1 bracket, and then union, parenthesis 5, infinity. Okay, the next example, part C, x minus 3 over x squared plus x minus 2 is less than or equal to 0. So we can factor the denominator. We need to know what the x values are that make the denominator 0. So it's nice when we can factor the denominator. The denominator is x plus 2 times x minus 1. So we might need more paper for this. So on another piece of paper, I'll write down this inequality and then use more space to solve it. Okay, so here's the inequality with the factored denominator. The endpoints are the x values that make the numerator 0 combined with the x values that make the denominator 0. So if we start with the denominator, one of the endpoints is -2, another endpoint is +1, and then the third endpoint is +3. So we can decide right now, or not, it's not really decide, we can decipher which endpoints will be included in the solution set and which ones will be excluded. So we always exclude endpoints that come from the denominator, so we're going to exclude -2, we're going to exclude +1. Those are the x values that come from the denominator. And then we either exclude or include the x value that comes from the numerator based upon the inequality. Since this is less than or equal to 0, we're going to include x equals 3. If you replace every x with 3, we're going to end up with 0 less than or equal to 0, but that's a true statement. It's the 0, it's the or equal to 0 that makes it true. Okay, next let's divide the number line into separate intervals using the endpoints -2, 1, and 3. So we have 4 intervals to test. So in the interval on the left, we can pick any number we want less than -2. So I'll pick -3. Then in the inequality, replace every x with -3. In the numerator, -3 minus 3 is -6. In the denominator, -3 plus 2 is -1, and -3 minus 1 is -4. So we have a negative number divided by a negative number times a negative number, which is going to be a -3/2. And the inequality is less than or equal to 0. So this inequality is true. So that means all of the numbers from -infinity to -2 are solutions. In the second interval, pick any number you want between -2 and 1. I'll pick 0. Replace every x with 0. In the numerator, 0 minus 3 is -3. In the denominator, 0 plus 2 is 2. And 0 minus 1 is -1. So a -3 divided by 2 times -1 is +3/2. And the inequality is less than or equal to 0. This time we get a false result. So none of the numbers between -2 and 1 are solutions. In the third interval, pick any number you want between 1 and 3. So I'll pick +2. In the inequality, in the numerator, 2 minus 3 is -1. In the denominator, one factor is 2 plus 2, or 4. The other factor, 2 minus 1, is 1. So we get -1/4 less than or equal to 0 is true. So all of the numbers between 1 and 3 are solutions. Then in the fourth interval, I'll pick x to be 4 and replace every x with 4. In the numerator, 4 minus 3 is +1. 4 plus 2 is 6. And in the other factor, 4 minus 1 is 3. So 1/18 less than or equal to 0 is false. So none of the numbers in the interval from 3 to infinity are solutions. Graphically, we're excluding -2, so we have a parenthesis at -2 that opens to the left, and then color in the number line to the left of -2. The other part of the solution are the numbers between 1 and 3. We're excluding 1, but we are including 3. So put a parenthesis at 1 and a bracket at 3, and then shade in the interval between 1 and 3. Okay, it's 8:50, but I'll just write down the algebraic notation real quick. This part of the number line is x less than -2. Then we use or, and then in this interval we write 1 is less than x, which is less than or equal to 3. And then the interval notation, we put -infinity, comma, -2, parenthesis, and then union, parenthesis, 1, comma, 3, bracket. Okay, that's all we have time for today. We'll continue the review tomorrow.